We are going to divide this polynomial using synthetic division, and that's going to allow us to use a faster shortcut or shorthand method to divide a polynomial, but only if there is a linear factor. So that feature is really important. You can't be dividing by x squared plus 1 or x cubed. It has to be a linear factor. So if we are going to do this, I'm going to write down a long division bracket, but upside down. I'm going to put the inverse of whatever is in this bracket. So here I've got x plus 4. On the outside of my long division bracket, I'm going to put minus 4. And then I'm going to write the coefficients across the top here, making sure I've got all the signs. I don't need any of the x's, but they do have to be in descending order. So this is the x squared column. This one is the x column, and then this one is the, or I'll put x1, x0, or the constant column. This is an easier method because we are multiplying and adding. In regular long division, we are dividing and subtracting. So adding and multiplying tend to be the easier of the operations. So first thing we're going to do is bring down whatever number is in that first column, and then I'm going to take whatever's outside, and I'm going to multiply them together. Minus 4 times 5, that is minus 20. And then I'm going to add the numbers in the second column together. So 14 minus 20 is minus 6. Then I'm going to repeat the process. I'm going to take whatever number's out in front, and I'm going to multiply. Minus 4 times minus 6 is 24. Then I'm going to add those two together. So I've got 35. And then I'm going to fill in the x's, but I'm going to start from the right. So the number at the very far right, this is my remainder. So I'll just say r at x. My term right beside it is my constant term, or my x0 term. And then the term third from the right is going to be my x1 term. So then I would say that the result of this division, if I was going to write the division statement, I would say f at x is d at x, my divisor, multiplied by my quotient, which is 5x minus 6, comes directly from my synthetic division result, and then plus 35. So let's check this on our first example using regular long division. So regular long division, I'm going to put my dividend underneath my square root bracket, and then I'm going to put my whole binomial or my divisor outside. First thing I'm going to do is take my first term and divide it by the first term in my divisor. So 5x squared divided by x, that is going to give me 5x. I write that on top of my long division bracket, and then I'm going to multiply through. So I've got 5x times 5x, which is 5x squared. 5x times 4 is 20x. And then I'm going to subtract those. So the first two cancel, lets me know I've done it correctly. 14x minus 20x is going to be minus 6x. And then I'm going to bring down my last term. I'm going to repeat the process again. I'm going to take my first term, divide by the first term in my divisor. This is going to give me minus 6. You should be making some connections between the fact that both of these numbers are also over here. Then I'm going to multiply through. So minus 6 times the two terms in my divisor. I get minus 6x minus 24. Again, I'm subtracting these from above. So my first two cancel out. 11 and 24, I'm actually adding those together, which is going to get me to 35, which is the same answer that I got using synthetic division. Let's try another example, only using synthetic division. So the first thing I'm going to do is I'm going to write my long division bracket upside down. I'm going to take the inverse of whatever's in my divisor and put it outside. So minus 1. If it helps, you can think of like you're setting your divisor equal to 0, and then you are solving for x. Then right off the start, I'm just going to write down my coefficients as they appear. This is incorrect because my terms in my example are not in descending exponential order. So my highest degree term needs to go first. That is my x cubed term with a coefficient of positive 1. My next term in there has to be my quadratic term plus 3x squared. Then I have my linear term, and finally I have the 8 at the end. So in my synthetic division, my coefficients need to go in that particular order. So the correct order should be 1, 3, minus 1, and then 8. That is important. The order matters. First step is I'm going to bring down the first number. That is a freebie. And then I'm going to multiply by whatever's in front. So minus 1 times 1 is minus 1. And then I'm going to add those numbers in the column together. So 3 plus minus 1 is 2. Then I'm going to repeat. I'm going to take whatever's in front and I'm going to multiply. Minus 1 times 2 is minus 2. And then I'm going to add those numbers in the third column together. Minus 1 plus minus 2 is minus 3. And then I'm going to repeat it one more time. I'm going to take whatever's in front, multiply by whatever's in that third column. I get positive 3. And then finally, I'm going to add those two together. So I get 11 at the end. Now I'm starting from the right. This 11, this is my remainder. Minus 3, I'll change colors for this. This is my constant term, or my x to the 0. The next term beside it, this is my linear term, my x to the exponent 1. And the third number here is going to be my quadratic term. So when I write out my division statement, I'm going to write it like this. I'm going to say f at x is equal to my divisor, so x plus 1, times my quotient, which is my answer, x squared, plus 2x minus 3 plus remainder, which is 11. If you want to be more precise, you can say that f at x is your original, it's that whole original question summarized in this division statement, which is addition and multiplication instead of division. And that is some examples of synthetic division.